Your plan is to teach your high school chem students all about calorimetry. Calorimetry, measuring the amount of heat released or absorbed during a chemical or physical process. So simple. All your students need is a styrofoam cup, a thermometer, some distilled water, and a balance to record whatever you're going to track. No, not that one. This balance instead, as it measures out to 2 decimal places. As part of a calorimetry investigation, you may have your students determine the heat of fusion of water simply by melting an ice cube, though not on the kitchen counter, but in the styrofoam cup. Or you use calorimetry to have your students determine the specific heat of a metal, say copper, or instead the heat of solution for a specific salt, for example, calcium chloride. In this video, I'd like to take it up a notch and show you how I have my students use food calorimetry to determine the amount of energy in a nut, though not using a bomb calorimeter. But before I demonstrate the use of an empty IPA can filled with water to determine the amount of heat in a nut, namely an almond, I'm going to take you through a riveting anchoring phenomenon to introduce the heat of a nut lab. You might be thinking, what does this image of Hadza tribe members trying to start a fire have anything to do with calorimetry? Well, it relates to a recent book released by a Duke University evolutionary anthropology professor named Herman Pontzer. And as this blog post states, Dr. Pontzer busts metabolism myths in his new book called Burn, with the subtitle, New Research Blows the Lid off How We Really Burn Calories, Stay Healthy, and Lose Weight. Or based on the more recent and less sensationalized cover, The Misunderstood Science of Metabolism. At the foundation of Dr. Pontzer's book lies his study of the hunter-gatherer energetics, in particular the Hadza tribe in Africa's Tanzania. The book is full of funny as well as educative stories that include conversations with the tribe's people, like the one about how sound enters the radio. Good question. And a story about how their problem-free philosophy keep the Hadza members' days filled with laughter, despite their hardship, including the occasional forest fire that may burn down their camp. And they express their chill attitude by saying the words Hamna Shida. So, if you're in a stressful situation, ask yourself, are you still alive? Is your family still alive? Yes? Then all will be okay. Hamna Shida. So what did Dr. Pontzer's research team investigate that is related to calorimetry? Using a technique called the doubly labeled water method, they compared the total daily energy expenditures of the Hadza foragers to people in market and farming economies. Pontzer's original hypothesis was that the Hadza people are very active and move on average significantly more, in particular 13 to 19,000 steps per day compared to your average person in market economies, the couch potato. And thus your average couch potato must expend fewer calories than the relatively active Hadza tribe members in a given day, or so they thought. Here we are looking at the results of this experiment. On the y-axis, we're seeing daily energy expenditure in kilocalories per day as a function of body mass in kilograms on the x-axis for the Hadza hunter-gatherers and for individuals in either market or farming economies. Highlighted here are the linear regression lines that represent the total energy expenditure either for men, the solid red line, or for women, the dashed red line. And much to the Pontzer's research team's surprise was that the Hadza hunter-gatherer, both male and female, very nicely fit on these linear regression lines, which means that their energy expenditure per day, on average, corrected for height and weight, is very equivalent to people in market economies. These surprising results challenge the view that Western lifestyles result in an abnormally low energy expenditure, and that decreased energy expenditure is the primary cause of obesity in developed countries. Not so. These findings are at the basis for Herman Pontzer's central argument in his book Burn, which is that humans have evolved a remarkably efficient metabolism, which allows us to maintain a consistent and constrained daily energy expenditure of roughly 2,000 to 3,000 kilocalories per day, independent of our physical activity. Hard to believe, right? But the data underscores this. So what do the Hadza people eat in order to meet their daily energy needs? Using handmade bows and arrows containing tips poisoned with desert rose sap. They hunt small game like bird, mice, squirrels, and hares, as well as larger animals like porcupines, hyrax, and perhaps even a zebra. They gather edible plants like tubers, wild berries, baobab fruit, and leaves. And they also harvest honey from wild hives, and they eat the honey, which is still immersed in the waxy comb. This wax is considered a lipid, which plays important roles in bowel health, digestion, and blood sugar levels. But the Hadza people's traditional lifestyle, which involves hunting and gathering, is in danger, as Western food is slowly infiltrating the Serengeti National Park where they live. Talking about food, let's bring the conversation back to the actual task at hand. How can we determine the amount of calories in a nut, namely an almond, using calorimetry? After adding about 50 to 100 grams of water to an empty soda or beer can, hang up the can using a ring stand and either a scoop or a stirring rod, as shown in the picture. Secure the almond by unfolding a paper clip that is stuck into a cork that's covered in a little piece of aluminum foil to prevent it from burning. For students not quite so dexterous, put the almond in an aluminum dish. Let's watch my students in action. After the almond has been secured, it needs to be lit in a butane burner. Place it underneath the can. Keep the thermometer stirring, and it can go up as high as 80 degrees Celsius. Attached here, you see a handout of the lab that details the purpose as well as the procedure of how to actually make this happen. A data table is provided that gives students an idea exactly what measurements they need to take and the calculations that need to be performed, including a % error and explanation. Obviously, the setup is very rudimentary, which means a lot of the heat can be lost into the surroundings. I actually found that most of my students observed an overestimate, meaning that there are more calories in the given almond than the nutrition label says. So we're going to do a little bit more thinking as to why this may be the case. So in this video, I've shown you how I conduct a calorimetry experiment with my students by using a very interesting anchoring phenomenon centered around the Hadza tribe members and their daily energy expenditure, which, despite their much increased daily activity levels, is on par with your average person that may not be so very active. After this introductory phenomenon, I've shown you how I then conduct the actual calorimetry experiment involving an almond. You might choose to use a different nut, although almonds are very nice and firm, so it's much easier to poke a paperclip into it and hold it in the butane flame. But you can use other food items if you so choose. If you're interested in this particular lesson handout and the associated key, simply click on the link in the description below. In exchange for your email, you will receive the link to this Google document with all different kinds of lesson resources and their associated keys. Thank you very much for watching. Bedankt voor het kijken. Tot ziens and see you in the next video.